Windows privileged access is where enterprise risk often becomes real. In this topic, we'll connect Active Directory power, attack paths, and practical controls like LAPS, tiering, PADOS, and GPO hardening to a stronger PAM strategy. We've already covered IAM and PAM foundations, Microsoft PIM, vendor platforms, and Linux privilege controls. Now we'll apply those same principles to Windows and Active Directory, where privileged access can determine control over the enterprise identity plane and the systems connected to it. Active Directory sits at the center of many Windows environments. It controls access to servers, workstations, applications, databases, file shares, and admin tools. That central role is powerful but risky. If an attacker steals a reusable domain or administrator credential, they may move quickly from one system to many. That is why Windows PAM is broader than password vaulting. It must cover domain admins, local admins, service accounts, delegated roles, and emergency access, while also hardening endpoints, enforcing least privilege, monitoring continuously, and limiting privileged sessions to just-in-time use. Privileged groups are where Windows risk concentrates. Domain admins can control domain-joined systems, so membership should be rare, temporary, and closely monitored. Enterprise admins reach across the forest, which makes them especially sensitive in multi-domain environments. Administrators can be more complicated, because it may mean local control on one machine or broad built-in administrative control in the domain. Older operator groups such as account operators, server operators, and backup operators can also carry more power than teams realize. The working model is simple. Identify scope, question necessity, restrict membership, and monitor every use. For the highest impact groups, treat membership as an exception, not a convenience. Domain admins and enterprise admins should usually be empty or near empty unless a specific administrative action is approved. Built-in administrators also deserve close scrutiny because default rights and inherited practices can hide unnecessary access. Privileged membership should be temporary, justified, approved, monitored, and protected with strong authentication. Review these groups regularly. Remove stale accounts, alert on membership changes, and never use them for everyday administration. Not every dangerous account is named domain admin. Some older or more localized roles can become shortcuts to the same outcomes attackers want. Account operators may change users or groups in ways that open privilege paths. Server operators can be risky around domain controllers and are rarely justified today. Backup operators may reach sensitive files, system state, or credential material. Local administrators can dump credentials, install tools, disable protections, and move laterally. Treat these groups as privileged. Audit them regularly, remove standing access, and replace broad membership with time-bound approved administration. Active Directory compromise is usually a chain, not a single jump. An attacker may start with one phished user or exposed service account, then enumerate what that account can reach, where sessions exist, and which permissions are misconfigured. From there, small privileges compound. Local admin rights enable credential dumping. Weak ACLs enable privilege escalation. Trust relationships enable lateral movement. The PAM lesson is broader than protecting domain admins. You also have to reduce the reachable paths that let ordinary credentials become powerful ones. Kerberos is powerful because users do not send passwords to every service. Instead, a user gets a ticket-granting ticket from the domain controller, then exchanges it for a service ticket. That trust chain is also where attackers look for leverage. Stolen cache tickets can impersonate users. Enumerated SPNs can expose service accounts to Kerberoisting. Weak or never rotated passwords make offline cracking practical. Delegation mistakes can expand access far beyond what was intended. Defenses include strong managed service accounts, modern encryption, close monitoring, and tight delegation reviews. The goal is to keep Kerberos a control, not an attack path. Now imagine an attacker compromises one workstation and gains local admin rights. The next move is often credential dumping, pulling secrets from LSS memory, registry hives, cached logons, or local account databases. If the attacker captures an NTLM hash, they may not need the password at all. Pass the hash lets them reuse that hash to authenticate to other Windows systems, especially when local administrator passwords are shared. Break the chain at multiple points. remove local admin rights, enable credential guard and LSAS protection, deploy LAPS, monitor with EDR, and reduce NTLM wherever possible. Kerberos attacks can also target tickets and trust relationships directly. In Pass the Ticket, the attacker steals a valid Kerberos ticket and replays it, so services believe the attacker is the original user. Delegation abuse works differently. It exploits which systems are allowed to act on behalf of users. Unconstrained delegation is especially risky because a compromised server may capture reusable tickets. Misconfigured constrained delegation, including resource-based constrained delegation, can open escalation paths as well. Defenses focus on spotting unusual ticket use, tightly limiting delegation, hardening service accounts, and auditing changes continuously. In Active Directory, privilege is not always visible at first glance. A user may look harmless because they are not listed in domain admins, but membership can flow through several nested groups until it reaches a privileged role. Delegated rights create another route. The ability to reset passwords, modify groups, or write to critical objects can become an escalation path. Local administrator access adds even more hidden privilege, especially when assigned by policy, scripts, endpoint tools, or manual changes. Always review effective access, not just direct membership, and use attack path analysis to expose these chains. Standing local admin rights are convenient, but they create a large attack surface. A user with permanent admin access can install software, disable controls, dump credentials, and help an attacker persist or move laterally. A safer model is least privilege by default, with elevation only when there is a valid business need. Start by discovering who has admin rights, classify true exceptions, and remove unnecessary access. For approved tasks, use a controlled workflow. Verify the user, approve the request, grant temporary elevation, perform the action, and log everything. LAPS addresses one common weakness: shared local administrator passwords. Each managed device gets its own strong, randomized local admin password. That password is written to a protected directory location, such as Active Directory or Entra-backed storage, and then rotated automatically according to policy. When support staff need emergency or break glass access, they retrieve only the password they are authorized to see. That retrieval should be delegated, logged, and reviewed. The security win is straightforward. Compromising one endpoint no longer unlocks the rest of the fleet. Windows PAM works best as layered containment. Tiering defines where administrative power is allowed to flow. Identity systems at Tier 0, servers at Tier 1, and user workstations at Tier 2. Pause give administrators a clean, hardened place to perform privileged work instead of using everyday machines. Group policy turns the model into enforceable rules, including credential protections, security baselines, remote access limits, and controlled local admin membership. Session control adds a broker between admins and sensitive assets, so access can be recorded, monitored, and audited. Together, these controls reduce blast radius and make privilege deliberate and visible. Windows PAM is about preventing one weak privilege from becoming domain compromise. Keep privilege groups lean and continuously reviewed. Hunt attack paths across Kerberos, credentials, delegation, and nested groups. Remove standing local admin, deploy LAPS, use tiered administration and pause, harden group policy, and monitor sessions. These practices set the foundation for cloud, Kubernetes, vaults, and full PAM program design.